Hello everyone. In this video we're going to look at what are called distribution diagrams. So in other words, graphical ways of representing distributions. And for this we want to basically group our data. So rather than having a list of every single individual data point, we group them into logical intervals. So the table that's given here is an example of data that is already grouped. The values that are between 0 and 100, there's 8 of them. Between 100 and 200, there's 11. 200 and 300, there's 24, and so on. Notice where the boundary points are included. So if I have a value of 200, for example, it's included in the second interval and not in the third interval. So generally, we'll only include the boundaries in one, so that if I have a value of exactly 200, I know where to put it. These are often used also for continuous data, so I might have something like 199.8 and so on. All right, so there's two different frequency tables I'm going to graph here on the same grid. One is called a histogram and one is called a frequency polygon, and they essentially show me the same data. We just graph them slightly differently. So in blue, I'm going to do a histogram, and histogram is basically a type of bar graph where the width of the bar shows me the interval. So for example, between 0 and 100, I have 8 data points. So I'm going to draw a bar that is 8 units high because the frequency is represented on the y-axis. And the width of that bar is going to be 0 to 100. For 100 to 200, I have 11 data points. So the bar that will span from 100 to 200 will have a height of 11. And so on. So 24 is the height of the next interval. So that bar goes up to 24. And then we have 15 for the next interval. So these bars are as drawn. And then we have 12. And finally, we have a bar at a height of 4 between 500 and 600. So this bar graph, the width of the bars represents what the interval actually is, and the height of the bars represents a frequency. So this allows me to see fairly easily how the data is distributed. I can sort of estimate the mean and the median by looking at the center of the data. So in the upper half of 200, probably, maybe getting close to 300. And I can go from there. Now, if I want to use my calculator to find the mean and standard deviation and so on, I can't find the exact ones because I don't know every single data point specifically, but I can figure out approximations. It's just on your graphing calculator, you can't enter an interval. So what we're going to do is essentially tell our calculator that these values are all 50. So we'll assume they're all sort of the average value of that interval. And the second interval, we're going to use 150, 250, 350, and so on. So we use these values. So essentially, we're telling our calculator that we have 8 50s and 11 150s and so on. Now, obviously, that isn't going to be exact, but it will give us a reasonable approximation. So instructions for how to tell your calculator to find one variable stats for grouped data are available in D2L. Depending on if you have a TI or a Casio, it's a little different. But essentially, in list 1, you would put these central values. And in list 2, you would put the frequencies, and then you would figure that out. So in this case, we find a mean of about 282. So like I said, in the upper 200s, which is sort of at the center of this histogram. And the standard deviation here is 135-ish, roughly. Again, these are approximations because I didn't have all the exact numbers. So 3 significant digits. So that's a histogram. A frequency polygon basically shows the exact same information in a line chart format instead of a bar graph format. So if, for example, instead of drawing a bar that's the width of an interval, I'm going to put a point in the center of the interval. So between 0 and 100, I have 8 values. So at 50, I'm going to put a point. At 150, I'm going to put a point at 11. 250, I'm going to put a point at 24. 350 at 15, 12, and 4. And then I actually need zeros on either side to show basically that those are my ends. And then I connect these. So this gives me a slightly different visual than the histogram does. It sort of smooths everything out a little bit more. But that is essentially, ideally I would be doing this with a ruler so I would have nicer lines. But this is what I get. This one in the middle is terrible. So the line graph is a frequency polygon, and the bar graph is a histogram. So frequency polygon in red. Now we don't usually do both on the same grid. I just am showing both things. You usually would do one or the other, either the histogram or the frequency polygon. The other thing that we can do is what's called a cumulative frequency polygon. So cumulative meaning as it goes. So what we need then is a frequency, a cumulative frequency. So cumulative would mean up to that point. So cumulative frequency up to 100 is just 8. But now the cumulative frequency up to 200 is going to be 19. Because basically the cumulative frequency means how many values are less than or equal to 200. How many values are less than or equal to 300 would be the 19 I already had, plus the 24 I've now got, which is 43. Then add on the next 15, so we get 58, then 70, and finally 74. The nice thing about cumulative frequency is I can tell right away, oh, there are 74 data points. But now what I'm going to do is I'm going to say before 0, or at 0, I had 0 values. At 100, I have 8 values. Now notice I'm no longer putting the point in the middle of the interval, because now I'm saying I have 8 values that are less than or equal to 100. So I want that point at the 100. Less than or equal to 200, I was at 19. Then it jumped up to 43. After 43, it went to 58. So at 300, we were at 58. Oh, I feel like I missed something. Oh yeah, this point is too close. Sorry, I screwed up my points here, so I'm just gonna, at 200, I'm at 19. At 300, we were at 43. At 400, we were at 58. 500, we were at 70. Less than or equal to 600 was 74. So this frequency polygon isn't going to close off at the end. It's a cumulative frequency means it just keeps growing. It's open-ended at the top. The nice thing about a cumulative frequency polygon is we can use it to estimate median and the quartiles a lot better than the frequency table. So when I did these one variable stats on my calculator, it gave me an estimate for median and quartile and the first and third quartiles, but those were just 250, 150, and 350 because it's treating them all as being the same value. The cumulative frequency polygon assumes that instead of having all 8 values in the 0 to 100 range, all of them being 50, they're probably more evenly distributed throughout there. So what I would then say is I have a total of 74 values. So the final number here was 74. So if I have 74 values, the median is going to be found when n is 74 over 2. So in other words, 37. So if I go to 37 and I figure out where that is at roughly 280-ish, let's say. And that we can call the median. So let's say the median is about 280, which is pretty close to what our mean was. Q1 is going to be what happens if I take that 74 and divide it by 4. So 74 divided by 4 is the 18.5, sorry. So again, if I go here to about 18.5, and these are just estimates because I don't have quite that precise a scale, but that's kind of around the 200 mark. So Q1. So the median was about 280. Q1 is going to be roughly 200. And then Q3 is going to be 3/4 of 74. So if I take 3/4 of 74, I get 55.5. So if I go to when n is 55.5, so kind of roughly here, and figure out sort of roughly what that value is, let's call that about 390. So that tells me what my Q3 is going to be. So Q3 is, let's say, about 390. So I can use this polygon to estimate what the median and the quartiles are.